All right. Um, so today we are going to look at a very important lesson. In fact, this is also known as a paradigm. We'll see what paradigm, the word paradigm means. We are going to look at object-oriented programming. We'll be starting off with the principles, the keywords connected to the object-oriented programming. We need to understand why we are using this programming principle, because there are other principles also. Sometimes the other principle look like very simple to use, and object-oriented may look like difficult to use. So people might ask, okay, why are we using a difficult method to solve problems? Because programming is all about solving problems. Yeah, they may look like difficult in the beginning, but when you start learning the principles, you will realize it is very natural, because object-oriented programming looks very natural. Natural as in the way we do things in our real world. Okay. So to start that, okay, so let's go through some slides. Now, if you go back to the ways of solving problems, right? Specifically, if you look at the software engineering as a process of solving problems, right? We call it a methodology. Software engineering is a methodology to solve problems. In order to solve problems, we use all kinds of programming languages, right? And these programming languages have different ways of solving problems. We call it paradigms. And there are lots of programming languages available, different paradigms are available. And if you look at some of these languages, like say old ones, like Smalltalk, Haskell, right? C++, Object Pascal, Python, stuff like that. Now, each one has a different way of handling solutions to our problems. Okay. And if you go back to the history of programming, right, you can classify these languages based on their features, right? Some languages actually can be used to do multiple paradigms. Some languages are specifically designed for a single paradigm. Likewise. Now, all in all, we break these languages into two kinds, right? Imperative, declarative. Of that, what we will be doing with Java is imperative. So under imperative, we have two kinds again: procedural programming, object-oriented programming. Procedural means you take a big program or a big project or a big problem, you break it down into components. And then you go through each component one by one and you finish it, and then you get your complete project at the end. That is procedural programming. Object-oriented programming also has a very similar approach. It's very similar. In that also, we are looking at breaking down a big project into small pieces. But in doing so, we also go one step further. That is, we go close to the environment where the problem is. Now, for example, if we are to build an accounting application, we walk into the accountant's room and then we try to see what are the physical objects the accountant has in his room. So we might be able to identify a checkbook, a bank statements, receipts, invoices, people, raw material, and then finished goods, stuff like that, machinery. So we see all these physical things in the office and also in the accountant's room. Then what we do is we try to emulate, or we try to do the same object. We try to create the same object using our software. Say, for example, I can create, let's say, something called checkbook inside my software. And in that checkbook, I will have lots of checks. If you take one check out of that, that check has from whom we are paying, that is from the company, to whom we are paying, from whom to whom, and the date of the payment, amount of the payment, and for what purpose we are paying, and who's authorizing it. Now, all that information is there in one check slip. And the checkbook has multiple check slips. Okay. Apart from that, we can also see he has tables, he has chairs, he has air condition, he has computers. So we can bring all that into a software system. Of course, we don't need to bring all that if you are building an accounting package. If you are building an accounting package, we are only interested in the accounting related material in his room. Nothing else, nothing about chairs and other things, right? So that's how we start thinking from, like I said, naturally in order to solve the problem. In that, we have a way of classifying things also. Okay. Now, if you take, say, for example, if you take vehicles, right? We have cars, we have vans, we have lorries, we have bicycles. They are all vehicles, right? And then if you look at all these vehicles, we can identify certain common things. Every vehicle has a wheel. Every vehicle has a horn. Every vehicle has a, some sort of an engine. And then every vehicle has a top speed, things like that. Every vehicle can have a fuel. Of course, if it is a bicycle, okay, no fuel there. Bicycle doesn't have an engine of sort, although they have like a gear mechanism. So, things like that. So, but if you take an airplane doesn't have a horn, right? Although we said vehicles have a horn, airplane does not have a horn, but they have wheels. But if you take a ship is a vehicle, but the ship doesn't have wheels, right? But it is also a vehicle. So we can identify vehicles as a set of similar things, right? We use the word class. A class of vehicles, we can see, right? A class of vehicle. And then every vehicle type has certain things that are very common. So when it comes to object orientation, let me switch back to Paint. Okay. So if you look at, let me bring in a picture here. Right. Now, if you look at this picture carefully, you can see, if you come to the right-hand side, you have cars, right? You have all kinds of cars. Down here, we have bicycles. Now, you have a car, you have a little van, maybe like not a van, it is also a car, like a wagoner, for example. We also call it a car. A bicycle, there are men's bicycle, female bicycle, racing bicycle, stuff like that. So these are the individual objects, we call them. And these objects can be classified, right? So these are bicycles, right? These are cars. And then cars and bicycles are also vehicles. So now if you take these into two sort of pieces, right? This piece is one, this piece is another. So this piece is known as classes. Okay. So there is a parent class which is on the vehicle. Vehicle is a parent class. Car and the bicycle is they are called the child classes. They are children of the vehicle class. And here we have something called the objects. The real objects made out of the class. Okay. Now, how do you sort of classify this? Now, first of all, when you look at the cars and bicycles and vans and ships and planes, we try to identify all the common things, like say wheels, for example, engine capacity, stuff like that. So from the children, okay, these are called children. This is the parent. Now, from children to parent, we are trying to identify common things, right? That is known as abstraction, right? So this is known as abstraction. So that is identifying what are the common things under children, and we are taking it to the parents. That is called abstraction. And when we make a child out of a parent, the children get something called inheritance, right? So the arrow is the other way now. So when a child is created out of the parent, the child gets something called the inheritance. Inheritance. Right? So you see the arrows both ways. When you look at set of classes and try to identify the common things and then create some parents out of that, we call it abstraction. And when we have children made out of parents, we call it inheritance. All right. So these are two words that we hear all the time when it comes to object orientation, making a class out of another class. Now, before we get to that, let's look at something simple, making an object out of a class, right? So that is the arrow, the arrow from here to here, making an object out of a class. There's a word for that also. It's called instantiation. It's called instance, in fact, right? Instance. Or the process is known as instantiation, right? Making an object out of a class. That is called instantiation. So let's try to do this and see how we can create a instance of a class so that we can see what is going on there. Okay, so I'm going to switch into NetBeans in order to do it. Right. So I did this in the class the other day. So what I did was I created a class called person, right? I did that by adding a new class here. By the way, when you're doing this, you need to make sure you do have a package name. So I need to use the same package name everywhere. So here I have a package name called week088.book1. And so this is my person class. And in that class, I have one property, one variable called age, In object orientation, we use the term property. Okay. And these ones, or the functions, are known as methods. Okay. And in this method, I have one called run. Okay. So all it does is just displaying something here. I need to pass on a variable called name, and it says name is running now. And in order to try that, test this, I have another class, which is my main class. And in that, I have a main method. So look at what is going on here. I'm creating one person called Sunil, another person called Nima. Okay. So when I'm creating the person Sunil, this is what I do. I say person, Sunil, new person. Now, if you remember the way we created a string, we did the same thing, isn't it? If I want to create a string, I would have said string, let's say student name equals new student, a new string, right? I could have done this. Oops, spelling mistake. New string, right? I could have done it, but generally we take a shortcut. We don't put this part normally. But this is how you actually create an object out of the class called string. And I'm doing pretty much same thing with the person class as well, right? Same thing. And then I am calling the age. Basically, I'm setting some variable there, age. So I'm passing number 20 to the age variable, which is here, right? And then I'm calling the run method with the name, Sunil. Same thing I'm doing here. In the second example, I'm not setting the age. I'm just calling the run method. I can add something else here also, basically. I can say name is something like this. No, I'll have a, oops. Is age old. Right, now let's run this and see what happens. All right, it says Sunil is 20 old. Oh, I need to fix my English. Years old. Let's run that now. Okay, Sunil is 20 years old. Sunil is running now. Nimal is 0 years old. Nimal is running now. Hold on. Why is Nimal 0 years old? Because I did not set the age of Nimal. And also, if you realize about the default values that we spoke about earlier, if you don't set a variable, the value is usually 0, right? So that is why Nimal is 0 years, because I did not give a value to Nimal. Whereas for Sunil, I did give a value. So it is showing that here, 20 versus 0. Okay. So what did we do now? This is an example of instantiation, right? So I can put it here. Class object instantiation, right? Or we can say making an object from a class. Let me put it this way. Instantiation equals making an object from a class. So here I am creating an object. Okay, so here creating another object, right, out of the class. So the class is person. Okay, I hope you understand what is happening here. I don't have a parent class and child class. I just have one class, and from that class, I'm making a child, right? Also, this is actually not good practice because anyone from outside the class trying to access the variable uh, of the class is not good practice. So what we do is rather than changing the age, allowing it to change. Now, for example, what if I give -20, right? If I play this, it runs. There it says Sunil is -20 years old, which is actually wrong, isn't it? Now, I could test it here without assigning 20. I can say, okay, what is the age? And then if it is less than 0, don't assign. Actually, less than 1, no, don't assign. Similarly, on the other side, like if it is less than or greater than, let's say, 120, not to assign. So far, people only live for about 120 years old. So if someone enters 150 or 200, that number is also not correct. So rather than testing it here, every time you pass a variable, I could test it inside here, isn't it? So for that, I can't allow them to access the variable directly. Okay, I should not do that. So I'm going to create a new project and trying to bring in something called access control to my variable. So I'm going to lock the control, thereby they cannot access it from outside. Now, actually, all I'm going to do now is put a word called private here, right? Now, see what happens when I do that and come here. I have a problem. You see, it says age has private access in person. And there's a red line here, which means I cannot run this program. Now, if I try to run it, there will be issues. See, one no more project work compiled with errors. It won't run. So I need another mechanism in order to get this going. So my next example is where I will use something called getters and setters to control what is going on with the properties. Okay, so let's create a new project. Let's call it W10A set get. Okay. Oh, sorry. What am I doing? Next W10A set get. Remove that and say finish. Okay, I have this one here. And I'm going to bring that person file back to this here. So I could do a copy and then paste it to the same default package. But then I need to change the refactor copy is what I'm going to use. New name project. Okay, I'll say refactor. Right. Now, if you look at, oh, I did not use a package. Oops. Okay. Let me do it from the beginning. I'm going to delete this whole thing. And new project. W set get. Mm. Okay, so I have person class here. I have this class here. I'm going to close the old project. Okay, person is here, and set get is here. Okay, I'm going to remove this unwanted thing here. Right, let's see whether this is running without any errors. Yeah, it does run. Build successful. So I can I can do the same thing that I was doing earlier, creating a person. Like for example, let me take only this one here and paste it here. Oop. Set get test. Or I can say example, right? Okay, so this does run, right? This is running because I have not set any access control. All right, so now I'm going to do some access control. So I'm going to say here, private. Immediately, my program is going to stop running because it won't run. Yeah, there is an error here. It says age cannot be set. So what I can do here is generate setters and getters. Let me see whether we can generate it from the IDE itself, right? Complete code. Right. This is the actually the concept is called encapsulation. So I'm gonna use the parameter or rather the method property called age, and getter will be get age, setter will be set age. All right, and the rest I'm going to keep as it is. So the fields visibility is private, but the accessors visibility, which is the method I'm using to generate, or rather actually not generate, to assign and change. Assign and change is called setting. Reading is called getting. So now if you notice now, my age property is private, but I have a public method called getAge. I also have a public method called setAge. So to this one, to setAge, I have to send a parameter called age, which will be assigned to the parameter here. And to getAge, it will take this age and return it to me. Now, by the way, I'm using the same variable name age here as here. So in fact, these are two different variables. So if you are getting confused, let's change that variable to something else. Let's say A. So this A will be stored into age. Now the word this means the variable within the class, actually within the object when you're creating an instance out of that. Now, I need to go and change something here. So rather than Sunil age, I need to call it set. Actually, I need to rewrite this whole thing. Now, when I put a dot, I get set age, right? And inside that is where I will be putting the age. Now it works. No errors. Let me run this now. There we go. Sunil is 20 years old. Sunil is running now. Now, similarly, I can call the get age to get the age. So I can, in fact, put that into system out print line, where I will be calling age equals plus Sunil. Now see, I'm calling get age, right? Now no errors, it's running. So let me run this. There you are, age equals 20. So I can set the age, I can get the age. Now remember, I said there is a problem of passing 20, right? Minus 20. That is still working, which is a problem. Now, what we can do here is we can actually do some logic in this piece. So for example, we can say if A is less than 1, not even 0, yeah, we will not accept it. Okay, we can either give a error message or we can set it to a 0 value. Now let's give an error message. For example, okay, now else I can assign it. So let's put an error message, system.out.println age cannot be less than 1. Okay. So, all right, now let's try it. There we go. It says age cannot be less than 1. So only 0 years old. All right. So the rest of the code is running, but we have an error here. Good. What if I give positive but 200 or 2000? Let's give 200. It will still run without error, but we know it's not normal to have 200. So that also we can try, right? So if you remember the way we sort of handle our mathematical expressions, we use operators, yeah? In fact, we use AND operators and O operators. So I am going to say the A must be, cannot be less than 1, right? So if A is smaller than 1, or if A is larger than, let's say, 120. So this means O condition. This or this, right? So this error message should be changed also. So age should be between 1 and 120. Okay. Now let's see whether it works. There we go. Age should be between 1 and 120. So what about 120? Whether that runs? Yeah, it is run. What about 1? Yeah, that is also run. So our logic is fine, isn't it? Now see, I brought the logic inside my person class, right? I did two things here. I protected the variable so that people can't assign wrong variables or invalid variable values to my variable. Two, I brought in the logic that I can use to check inside here also, isn't it? In fact, there is a word for this. It's called encapsulation, right? Encapsulation. So a capsule is like a any medicinal capsule. We don't care what is inside the capsule as long as it does the job. So say if you take Panadol, for example, you take Panadol and then it takes away your headache, for example. But we don't know what that white color thing contains, or we don't care actually, right? Same story here. So if we come here, when we say set age, we don't care how it is done or why it is done that way. But if you make a mistake, it comes back and say, look, you can't go less than 1 or more than 120. So this concept is known as encapsulation, right? So here I can say encapsulation example. All right. So we learned a few concepts today, right? We learned about abstraction. We learned about inheritance. We also learned about creating instances. And now we learned about encapsulation. So these are the big words that we use when it comes to object orientation, right? Then, although we did not write an example of abstraction and inheritance, but the rest we did, okay? All right, so the next one is going to be looking at creating some sort of a parent-child instance. So how can we create, now person is just a person. Well, how about types of person? Now we can have, if you take SLTC campus, we have staff, right? Staff can be again broken down, academic staff, admin staff, and then we have students, okay? So maybe we can break them into two, students versus staff, right? And then we can then start putting parameters and properties and methods to these classes. Now, for example, the students will have a student ID, staff will have a staff ID. But both of them have a NIC, name, mobile number, stuff like that. So we can structure that in a way so that when we create a object out of a class, we can pass some parameters automatically as well, right? So in fact, in object-oriented principle, there is a concept where when you are creating a person, now, for example, here, rather than doing it in 2 steps, I can create the object and also pass the parameters to it. Now, that is called calling the construct. Okay. So let's do another example about how to create a class, actually, sorry, an object, but at the same time creating a construct, rather calling the constructor and then also creating sample data. All right. So constructor is our example. There we have it. Now, this time also, I'm going to copy my person class. I'm going to use it here. Paste. Right. So I'm using the same thing. So we have here. Right. Now, this time, rather than, okay, let me also copy code from the previous one here. Okay, I'm going to do this whole thing and then paste it here. Oop. Example. Yeah. So rather than sending this like this, what if I can send the age like this here? right? Something like this. Yeah, I do have a problem because I can't pass. So there is a red color line here. So in fact, I can press Alt Enter and see what kind of suggestions it can give me. So it will give me two suggestions. It says change constructor from person to person int par, create constructor person int in person. So I'm going to take the second example. So when I click that, you go here. Let me close the previous project. Now you see a new method automatically created. Okay. So of course, it has also added this here. It says throw new unsupported operating. So I'm going to delete this guy because I am going to set this dot age into the I. Okay. What does that mean? Also, carefully watch. Now, my name of the class is person. Method name is also person. Whereas the method name here is run. Now, here the method name is similar to the class name. So that is called a construct. Okay, so this is called the constructor method. Okay, constructor method is called automatically when you create the class. Actually, sorry, when you create an object. Okay, now it is working. Now see, I'm creating an object of person and passing number 20. Then it is automatically assigning 20 to the age. And when I run Sunil run, I see it there. And I can, in fact, get that number by calling get age. So when I run this now, there we go. Sunil is 20 years old. Sunil is running now and age is 20. So this is another mechanism in object-oriented principles where we can create an object out of a class. At the same time, we can also pass on the parameters to that class. And this is called using the constructor. Okay. Constructor example. Right. My next one would be to create a child out of a parent. Now we are only having parent classes now. Actually, parent classes. So we are trying to create a child now. So to do that, we need to figure out something. Now, like I said, we have a person. Then we need two more child classes. We need a staff and a student also. So let's create a new project again. And let's call that child class example. And yeah, I'm going to copy my person again here. I use refactor copy because if it requires any changing, that will be applied here as well. So now rather than calling the person, I don't want to call the person. I want to call, because the person is very generic. I need to create another class, let's say student class. So let's create another new class here. So I'm going to say new Java class. Okay, so the name would be student. All right. So I'm going to say finish. Oh, it created a class. Now, remember I said this is going to be a child, but then this doesn't look like having any connection to the person here. So what we can do is we need to add something additional here. We need to say extends person. right? What does that mean? It means I have now made student a child of the person, right? Student child class of parent class person. Okay. Now it's red color because I have a problem because although I am calling the person, I have to actually, although I'm extending the person has a constructor. The constructor is expecting a variable. So I have to pass something to the person. So there is still alt enter. Oops. Alt enter gives me this. So it's giving me a lot of suggestions. Add constructor, student int. Okay, let's do that. Okay, red color is gone now. Also notice I created another constructor, student constructor. It is expecting a variable, and that variable is not used here. It is passed on to something called super. What is super? Well, super is called the parent class. So it's actually passing the I to this class, which is here, right? The student. So when I create, let's say, a student this time, not a person, right? Let's see what happens. Let's create, okay, let me get some stuff duplicated here. So go back here, here, oop. This is called inheritance actually. Okay. I'm gonna, you notice I'm also adding comment as I, do my work, because then later I can generate documentation automatically and it will have all the documentation I will need. All right, so OOP inheritance example. Now this time I am not going to create a person. I am going to create a student. All right, so let's see how it works. So I can say student. Okay, who is a student? Let's say Malini. Oops. New student. Right. I can't finish this because there is again a red line, because the student actually student has a constructor which is requiring a variable. That variable is actually passed on to the person parent. Now I have to give something. So let's say 25 here. How it works. Okay. And then let me see whether I can get the age of the student. Can I do that? All right. Let's see whether I can get it from here, this line. So I go and say, okay, this time it's Marlin, right? Yeah, it's working. See, there's no red line. Right, let's run this and see whether what happens. It's working. What is going on now? My student class does not have get age, isn't it? It does not have get age. The get age is actually in the person class, right? Here. But because student is a child of person, because it's extending person, it has access to everything the parent is giving. That is why we call it inheritance, right? So we can say student is inheriting person, right? That is what is happening here. In fact, I can create another class. Now this time I can do some automation. I can say new Java class. Let's call it staff now. Okay, I'm going to select, person here. Person. Actually, it is bringing all the classes from all the projects open. So I am only interested in this one, the child class. So I'm selecting that and say OK, right? So I'm automatically bringing the person this time. Remember, I had to type previously extend a person. So here I did not type that. It came automatically, right? And also here, remember, we had to add another constructor. So I need to do the same thing. Add constructor, staff int. There I go. So here, I don't need this guy because I'm in the same project. All right. All good. Right. So I can create similarly a staff, right? Staff. Let's say Trimal, new staff. And of course, I had to pass some value, just like that. Okay. I'm going to take a copy of this one and see whether I can access the staff get method. Right? Yes, it is working. Let's see. Yep. Age is working for student. Age is also working for staff. Right? Isn't it? So what did we cover now? We covered a lot of stuff in our object-oriented principles. So we covered encapsulation. We covered accessing the encapsulated items through setters and getters. We covered constructor, which is basically a method that gets called every time you create an object. We also covered a child class, which is inheriting from the parent. The last one we have here is called polymorphism. That's a interesting concept, actually. Now, what happens there is now the parent class might have, let's say, a certain method, right? But the child class, the parent class has a method. The child class gets the method because it's part of the parent. Now, example is run, isn't it? Now, I can say Malini run, like I did here. Where was that? I think it was here. Right? Say, for example, I could say run, isn't it? So, and give it a name. So, if I go here and say Malini dot run and then give a name, right? And similarly here, I can say Srimal dot run, right? When I run it, when I execute the program, you can see they are still working from, or rather they're getting called from the parent class. So everything is fine. Everything is working. Okay. Now, what if the run method requires, let's say, a different way of running? Let's say the student can run faster. So what if I go back to this and rather than just saying run, if I want to change some of these things, right? So for example, I can copy this to student, right? So now I have two run method. I have the student's run method. I also have the parents run method. So let me put the Where is person? Okay, person. So I'll put this here in bracket, and in the student, I put this in bracket. Now, when I say run in this class, what is getting run? Right? When I say Malini run, it is actually calling the student version of the run. Whereas for Srimal, when I call run, it is calling the parent method of running. Right? Why is that? Because Malini is a student and the student has a run method. Okay. Now, this is called polymorphism, meaning you have the same method, but the way it is running, the way it is executing is different, although it is a same sort of a method, right? Now, this concept, although looks very simple, is there so that both classes have the same method. Actually, it actually has a little bit of a problem, meaning, let me quickly switch to our Paint program. The problem is this. Problem is your memory, the memory for the program now requires memory for two methods, isn't it? So you have parent class, or the person in our case. You have student, okay? So here you have person, here you have student, right? And we have a run method here, and we have a run method here. So if you look at the amount of memory that is required, this is waste, isn't it? We have a run method here, and we have another run method here. So when I create, let's say, Sunil, what's actually going on? Sunil as a student. No, actually, my student was Malini, right? So when I created Malini, the student, right, what's actually happening? So Malini is inheriting from student, right? So Malini has run from the student class, but student is inheriting from person, isn't it? So Malini actually now has two run methods. Now that's a bit of a problem, right? So now what do we do? Now what do we say? Okay, don't run the student method. But what if we need to run the parent method? Yeah. So we have a problem there. Or what if we don't want two methods? We want only one method to save memory. Okay. In that case, we type a small line on top of the run method of the student with the @ sign saying override. Right? We say override. Now, what does that mean? Remove the run method from person and use only the student run method. Right? That's called overriding. So to the student, we say, don't use that parent method. Okay. Let me switch it back to code. Okay. So I've added override here to the student run method with the O capital. Yeah. Now this time, of course, you get the same output, no change, but the memory wise, my code is efficient now. Okay. So this is called polymorphism, right? Poly mean more, morph mean many faces, actually morph mean face. So poly mean many, morph is faces. So polymorphism mean many faces. So meaning we have run but two runs. We have a child class run and the parent class run. And here we are replacing the child class run from the parent class run. Okay. So we covered a lot today regarding the object-oriented principles. So we covered, again, we covered a very basic object orientation, the concept of class and object. Then we realized the importance of hiding the class parameters, or we call it properties, so that other classes cannot access them directly. So for that, we use a concept called encapsulation. We did that by using something called setters and getters. Then we looked at passing parameters as we create the class or the object. And that concept is called constructors. Then we also looked at creating child classes out of the parent class called inheritance. And then finally, we looked at creating same method the parent has, and then we override that, and that is called polymorphism. Okay. So I'm going to stop now. This is a lot of stuff on object orientation principles. I guess this is enough to work on the assignment now. I will upload the assignment document in a day or two. You can have a look at it.